On with our presentation to understand how electricity works or what triggers electric current. For this, let's look into some basic concepts. What is an atomic structure? How does it look? We know that everything is made from atoms, including you. Different materials have different types of atoms. To see the atomic structure, let's observe the figure beside. In this structure, at the center of the atom, at the core of the atom, is the nucleus. This houses two particles known as neutrons, which do not have any charge, or we can say they have no electrical charge. The other subatomic particle in the nucleus is the proton. The proton has a positive electrical charge. Surrounding the nucleus are different orbital shells which move around the nucleus. They look like flight paths. What do they have in them? What do they have embedded in them? We can see that these subatomic particles are revolving around the nucleus. Which are they? Let's recall. They are called as electrons. These electrons travel long paths, much similar to your satellites which orbit around our planet. Except that the electrons travel at almost the speed of light. The negative charge of the electrons is attracted to the positive charge of the proton which is inside the nucleus. And as we have already seen, unlike charges attract each other. That is why we can say that the atom is stable. Each orbital shell can hold a set number of electrons. Atoms hold onto their electrons tightly, but some materials will hold onto their electrons more tightly than the others. The outermost orbital shell, over here it is the second, is called as the Valency shell. And in this shell, some materials have loosely bound electrons which can float to the other neighboring atoms, and they are the causes or carriers of electric current. So children, we have understood what is a Valency shell. It is the outermost shell of an atom which contains loosely bound electrons which can trigger electric current. But do all materials allow electric current to pass through them? No, definitely not. We have seen that it depends upon the type of material we use. To recall, there are two types of materials called as conductors and insulators. Then, what were conductors? What were insulators? Let's see. Conductors, to begin with, any material that allows electric current to pass through it was called as a conductor. The different examples of conductors, as we can see, are copper, aluminium, steel, or any other metal. What are insulators? Any material which do not allow electric current to pass through them. They are like protective coating on wires. Here we can see a combination of a conductor which can allow electric current to pass through them and a protective coating which is made of an insulator which does not allow electric current to pass through it. Examples of insulators are plastic, rubber, glass, or any material like cloth. So now we have understood what are conductors and insulators. Ones which allow electric current to pass are called as conductors, which do not allow electric current to pass through them are called as insulators. What are conductors and what are insulators? Materials which can pass electrons are known as conductors. Most metals are conductors. atoms which do not have loosely bound or free electrons, and they are not conductors of electricity. They do not trigger electric current to pass through them, are called as insulators. Materials like glass and rubber are good examples of this. We can see cables in and around our house which are carriers of electricity. Looking into the figure aside shows you a similar figure. Here we see that conductors and insulators are combined together to safely use electricity. This is done by surrounding the conductor, which is made up of a metal, by the insulator, which do not allow electrons to flow, but it restricts where they can flow to. This is how cables and wires work. So now let's move on to understand what we see. To understand in more detail how electricity works. If we can see both the figures in front of us, we can understand the difference. Towards the left, we can see that there is no current, no flow of electrons through the external part of the wire. Why? Because there is no potential difference. There will be no potential difference in the absence of any cell. But over here, we can see the flow of electrons in this circuit as soon as the potential difference is applied. And how do you create this potential difference? Who creates this potential difference? It is the cell that is creating or triggering the flow of electrons through the wire. So thus, when we look inside the slice of a copper cable, which is a conductor, we would see free electrons of the atoms, but moving randomly in any direction from one atom to the other. But when this same wire is connected to a cell, which becomes a source of power, the electric potential will force the free electrons to move from one terminal to the other terminal of the cell, and that will cause them all flow in the same direction. A unidirectional flow of electrons is created to try and get back to the other terminal of the battery. So what did we see over here, students? We saw that when no current applied, the free electrons within the copper atoms will move randomly between all the atoms in the neighborhood. But with current applied, that is when potential difference is applied by connecting the wire to a cell, the electrons will move in the same direction between other atoms, and that causes electric current to flow. Now that we know what makes electrons to move in a circuit, what triggers electric current to move in a wire, that is the potential difference that we apply. But how is this potential difference created? It is created by connecting the wire to a cell. So let's move on to understand what is a circuit. The term circuits refer to a route which the electrons can flow along to get between the two terminals of the power source. And which is the power source? The cell. In fact, the cell contains the two terminals, one a positive one and the other called as the negative terminal. These two terminals are created because of the potential difference applied, which triggers the electrons to move, which in turn makes electric current pass through the wire. So, when a cell, a plug key and an electric bulb, a cell, a plug key and an electric bulb are connected with wires, the bulb lights up by closing the plug key. This type of connection of electronic components is called as electric circuit. So which are the different components which make up an electric circuit? It is the cell, the wires, the plug key and the bulb. So when a circuit is closed, the electrons can flow from one terminal of the cell to the other terminal of the cell. We can place electrical components in the path of free electrons which flow in a circuit. This will force the electrons to flow through the component, that is the bulb, and this can be used to perform work such as generate light. When a circuit is open, then there is a gap in the circuit, so electrons cannot flow, and in turn the bulb is not lighted up. So this figure shows you a closed circuit and this figure shows you an open circuit. Now that we know how electric current is made to move through a wire, how is it produced? Electric current is produced due to the flow of electrical charges, or you can say charged particles. A source is required to produce a uniform flow of charges in a circuit. Such a general device is called as an electrical cell. Various types of electrical cells are available today. These are used in a range of machines from wristwatches to submarines. The main function of various electrical cells is to maintain a constant potential difference across the two terminals. That which we know of is positive terminal and the other as the negative. The main function of various electrical cells, thus we have seen, is to maintain a constant potential difference which triggers the electrons to move unidirectional and in turn makes the current flow through the wire. The electrical cells work on electrical charges to maintain a constant potential difference. Thus, an electrical cell is a device which converts chemical energy into electrical energy. It has two terminals which are made up of metal. One is positive while the other is negative. When these two terminals are connected to an electrical device, an electrical current flows through it. The cell pushes the current from positive terminal towards the negative terminal. As we have seen, water always flows from a level at a higher height to a level at a lower height. Same is the case of movement of current. The flow of current, it is always from a terminal at higher potential to a terminal at a lower potential. So the higher potential terminal is always the positive one. The one with a lower potential is always the negative one. So a cell pushes the electric current from the positive terminal round to the negative one. This is the way that conventional current flows. It is just the opposite of flow of electrons. The electrons always flow from the negative terminal towards the positive terminal of the cell. Thus, an electric current is produced due to the flow of electrical charged particles. Now we have seen the potential difference that is created. What was its unit? The unit of potential difference was volts, as we have seen earlier. Now, electrical charge flowing through the wire in only 1 second is called as unit current. The flow of electrical charge through a wire in 1 second is called unit current. The SI unit of electrical current is coulomb per second, or you can just say the SI unit of electrical current is ampere. It is a scalar quantity. Now, we have seen what are scalar and vector quantities earlier. Scalars are quantities that are fully described by only their magnitude or numerical value alone. And what were vector quantities? Vector quantities were fully described by both magnitude as well as direction. So children, electrical current requires only magnitude for the description. That's why they are scalar quantities. Thus, perhaps the most amazing and life-changing innovation made by humans is electricity. Survival without electricity is unimaginable now, but there was a time when people lived without light and electronic appliances. Great minds worked in coordination to create this essential asset for the human race. Development and generation of electricity changed the lives drastically, starting from domestic use to industrial activities. Talking about domestic usages, there is hardly any task that does not require electricity, like cooking, cleaning, entertainment, and whatnot. On the other hand, if we look at the commercial and industrial sectors, all the technology is dependent on electrical devices like TV, kitchen appliances, computers, video games, vacuum cleaners, and much more. So children, we have seen what and the importance of electricity. We have seen the two types of electricity, that is static and dynamic. Static electricity is the electricity that is created by rubbing two objects. Dynamic electricity was the electricity produced due to movement of electric charges. But who exactly are the carriers of these charges? They were the subatomic particles, the electrons. There are billions and trillions of protons and electrons contained in any object around us. In some objects, the electrons can move randomly, that is metals, but in non-metals, it is fixed. They are not movable. In any appliance, children, in our house, say for example a tube light, it works because of the negatively charged electrons moving unidirectional in a wire, and the wire is made up of a material called as metals. They are metals which are good conductors of electricity. This energy for the movement of electrons through the wire is supplied by the transformers. These transformers supply energy which in turn make the charges move, and in turn our appliances work. A flashlight, if you take, also works on the same principle. Built here, the energy is supplied by the cells or the battery of cells which are used. So children, dynamic electricity is the electricity produced due to the movement of electrons which triggers the electric current. Thus, we will see now how exactly does electricity flow through a circuit. How electricity works. What makes the bulb glow? Electric circuit, as we have seen, it is the path along which electric current flows. Here we can see a closed loop is formed by connecting the cell, wires and bulb. It is a closed path. All the terminals of the bulb as well as the cell are occupied. Here the electric current is flowing along a closed path. Then how does electricity flow through the circuit? We know that electric current is triggered due to the flow of electrons from the negative terminal towards the positive. The negative terminal of the cell repels the electrons in the wire. The wire is a conductor. It allows electric current to pass through it. The negatively charged electrons from the negative end drift away from the negative terminal, but in process they repel the neighboring electrons. Why? Because like charges always repel each other. In other words, they transfer some of the energy to the neighboring electrons, as you can see. So, over here, the neighboring electrons are also pushed away. Then in turn, they transfer the energy to the next neighboring electrons. Thus, this process continues throughout the circuit till they reach the positive end of the cell, the positive terminal. Thus, children, electric current was the flow of electrons in one direction. But to be more accurate, in reality, do electrons actually move from the negative terminal to the positive terminal of the cell? No, but electrons slightly drift away from their original position and transfer their energy to the neighboring electrons. This is because the wire is a solid object. So, no space available, no place available to move or the electrons to move away. But electrical energy transfer takes place from one electron to the next neighboring electron. And this is how the electrical energy transfer takes place throughout the circuit. So to be more precise, how does electric current move? It is actually because of the flow of electrical charge through the circuit. The electrons in the copper wire transfer the energy to the electrons in the metal wire, or they move the electrical energy to the neighboring atoms connected, and they get transferred slowly towards the positive terminal of the cell. This energy, as you can see, also flows through the filament and out from the second terminal. So this way the energy is transferred from one terminal of the bulb to the second terminal out into the circuit. But how does the energy flow between the filaments? What makes the bulb glow? So here, children, when the energy gets transferred from the wire to one terminal, it moves across both the filaments, and as we know, the energy gets converted, the electrical energy gets converted to heat energy, and it heats up the filament in the bulb, and this is in turn makes the bulb glow and give us light. So there is a transfer, a conversion of energy from electrical energy to heat energy to light energy. So as long as the circuit is closed or till the battery or cell does not die out, the current flows and the bulb glows. This is the way electricity works.